Students, I think you know what is a Cartesian product. Cartesian product, that is written in the form of A cross B, and it is a set which contains all the ordered pairs. That means the elements are in the form of A comma B, where A is coming from A and B is coming from B. So it is a set which contains all the ordered pairs. Now what is a relation? So a relation is always subset of A cross B. Then it is always subset of A cross B, which contains some elements of the Cartesian product. This is the meaning of the subset. Then now in a relation, particular conditions are given sometimes. For example, it is given that you have to choose only the even numbers, a set of the even numbers, set of the odd numbers, set of the prime numbers, such as. So that's why this set is called subset of the Cartesian product. But in a Cartesian product, you have to take all the ordered pairs. This is the difference between the Cartesian product and the relation. Done. Now see, here it is a definition of this relation. That means if A comma B belongs to R, then we write it as A is related to B, and we read it as A is related to B. That means it is a set and which contains always elements of the form A comma B. Then and A and B are both are in a relation if they satisfy all the conditions of that set. Okay. Okay, now after this, we see here these are the three most important definitions of the relation. The first is that is a reflexive relation that you have seen in the plus one, but I think you don't remember that one. The relation that a relation R in a set A is called a reflexive if and only if A comma A belongs to R, that for all A belongs to R. So it is a written definition of the reflexive. Reflexive means a relation with itself. It is came from the reflection. Reflection means अपनी ही reflection को देखना. That is called reflexive. So when we relate a relation with itself, that is called your reflexive relation. Okay, and after that the second relation is that is a symmetric relation. Now see, a relation R in a set A is called asymmetric if A comma B belongs to R. This is imply B comma R, B comma A belongs to R for all A comma B belongs to A. Suppose A is a set, done, and you have take two elements A comma B. If in the symmetric relation he said that if A comma B belongs to R, if A and B both are belongs to R, then in any case if B comma A also belongs to R, then it is called symmetric. Otherwise it is non-symmetric. Otherwise it is called non-symmetric. So for the symmetric relation, it is a very important if A comma B belongs to R, if A and B, this pair is belongs to that set, if that lies in set, then B comma A is also belongs to R, then that is called symmetric. For example, if 2 comma 3 belongs to R, then 3 comma 2 is also in that set, that is called symmetric relation. Okay, after this, see the very important relation, that is a transitive. Now in this set, yeah, in this relation he said that if A comma B belongs to R and B comma C also belongs to R, and these are two results are given, but after this he said that if A comma C also belongs to R, okay, if A comma C also belongs to R, then we say it is a transitive. Okay, for example, if you have to given, for if you have to given 1 comma 2 belongs to R and 2 comma 3 also belongs to R, then 1 comma 2 is also belongs. Now see, I am taking one of the example. It's a question number first, fourth part. In this set, Z is a set of the integers and your R is given, that is called your x comma y, where x minus y is an integer. He said that if x minus y, if we subtract these two and if its answer is equal to integer, then they are in a relation. So these are the condition of this set. Okay, he said that in this set only those pairs are lies if their subtraction gives the answer is an integer. Okay, so now see for the reflexibility. Clearly we write here clearly x related to x. That means we know, I think everyone know this thing, that x minus x, that is always a 0. That means if we subtract some integer from integer, that gives the answer is also integer. Okay, 0, that is an integer, so that's why we say R is a reflexive. Similarly for the second relation, that is a symmetric, see if x is related to y, that is a given. Okay, that means x minus y is an integer. Then we have to prove that y minus x should be an integer. So clearly we know y minus x is an integer. No doubt the sign of that answer will be differ, but no problem, but that is also integer. So that's why R is called also symmetric. Okay, so in this way you can prove the symmetric relation. Okay, after this, now see the third relation, that is a transitive. In this relation he said that if x is related